You have to start thinking differently when you think about HPC in a cloud environment, right? So we've had, decades of experience of fixed resources running really complex computational problems. And, one of several things happen. You wait, you have customers or users waiting in a queue to get time to run on the machine, or you right size your applications and your problem sets to fit on that environment, or, certain kinds of science just can't get done because you just don't have the scalability. So when you think about HPC in a cloud environment, all of those things actually disappear. At AWS, we think about how you would reimagine HPC in a cloud environment from the bottom up. How do you think about the network differently? How do you think about your instances and your scalability constraints and opportunities? And how do you think about enabling the range of workloads that you would typically think in an HPC environment in that kind of elastic cloud infrastructure? And so when you think in that framework, we're not looking to rebuild an on-premise environment in a cloud. We're looking at what are the opportunities to reimagine these kinds of workloads in a cloud environment. So it's fun and inspiring because finally we get to think about providing infrastructure and big compute for everyone. Small companies, big companies, new use cases, getting the plumbing right, making sure we have enterprise-ready infrastructure to spin up and deploy clusters, making sure the networks are fast, making sure we have all the right instances. But the big vision, as you think about it, is how do we make it easier, more scalable, more performant, so that we can really expand the domains that we can service over time. So when we think about the path forward, it's building on all the goodness that we've already created with our products. Our parallel cluster product, which is how you create and manage a cluster in an AWS environment from a tightly coupled as well as a loosely coupled environment, to our batch scheduler, which is our cloud native scale scheduler, which allows you to scale extreme numbers of containers in the AWS environment, to our elastic fabric adapter, which is our high-speed network, which leverages the scalability dynamics of and capacity of the AWS infrastructure. It's a sort of a variant, a different methodology of how you can scale real high-performance networks. And our Engine Prime product, which is our GUI-based on-premise portal that allows you to manage your on-premise clusters as well as through our Cloud Connector burst to AWS. So we're thinking about where customers are today and how they leverage that, and then building on that going forward with some fundamental things about ease of use and scale. I want to paint a picture, right? So the industry, again, has been living in kind of this fixed resource mentality, right? And so it artificially constrains, not even artificially, it actually constrains the opportunities. What if you remove those boundaries? You have agile, scalable infrastructure, and you pay for what you use. You don't have a fixed asset that you're paying for whether you're using it or not. You have the ability to not have people waiting in the queue. Think about all the science and engineering and creative work that can get done if you don't have people waiting in the queue, as well as the problem sets that you could actually go answer. Let me give you a concrete example of that. So about 6 months ago, we're about to do phase 2 of this extraordinary project. And this project, as I'm going to share, I get chills every time I think about it. It's very personal to me. So Harvard Medical School, they have a platform called Virtual Flow. It is an open source platform that allows you to do extreme scale virtual screening of molecules for targets, and they work specifically on rare or highly mutated cancers, which are the bane of existence in terms of finding the right therapeutics to attack those. Virtual screening has been around for a while, computational drug discovery, but not at the scale we're talking about. And what the cloud allows you to do is remove all of those constraints and see what's possible. So round 1 of this, we built out a 5 to 10 billion molecular compound database. That was docking ready, meaning that as you screened it, it would identify those targets that were dockable to sort of hit those rogue elements, in particular highly mutated cancer targets. And we ran it on a million CPUs, 2.2 virtual CPUs, and that's just phase 1. And what we were able to do is the goal is to find those targets, right? Like, can you begin to take that massive surface and hone in? And the first run of this is already yielding some extraordinary results. So that's the stuff that, we don't get up in the morning just to go build a cluster. You get up in the morning because you feel like you're working for something much more purposeful. It's something much more inspiring. I mean, the things that just couldn't be done before, you can now do because of the scalability and just the extreme, capacity. Everything from what's happening around us in climate to food security to issues around human displacement, disease, public health. These are the problems of our generation. And so where does HPC fit into that? Well, when you start thinking about the complexity of these problems, and these are multidimensional problems, they're not single, and there's humanity involved in these things. So it's not like a fixed point. You have to evolve your analysis and your understanding of the dynamics that surround these things. And so as an organization, we spend a lot of our time thinking about and working with our customers and organizations on what role we can play. How do we start thinking about engineering solutions that can scale through communities and marketplaces that can go solve the hardest problems? And so impact compute is a big part of our strategy. It's a big part of what we do. It's not about philanthropy. It's about really sustaining change and impacting the lives of the 7.x billion people on this earth. And so stay tuned. There's all sorts of really fun things coming along that way.